What's today's date? 10. I think most of them not coming today. They have quiz tomorrow.
Oh, okay. Oh, I was thinking to extend today's class.
Oh, really?
Because I will be on leave on 24th.
24 is
March.
Friday lah.
Yeah,
so
Friday.
Then,
So
but that's next week, eh?
yeah, it's next week.
Then next week then extend.
But we need 2 extensions.
Oh yeah. Huh? Was it? Next week? 2
Yeah.
sessions?
next week.
Oh yeah.
Wow, that means
Or
next
maybe
week 7 to
you
10.
want to-
No, that cannot.
Next week 7 start, right?
Yeah, next week.
Oh, yeah,
I want all of you to attend the lecture summary.
Yeah.
Yeah.
That was only for the whole cohort, or only for those selected.
No, it's
No,
for
everybody.
everyone,
Everyone.
but it will be a 2 hours lecture and it will be a summary lecture. So, and it is conducted by Prof. Chang,
Chan.
Chip Hong, right? So yeah, better attend.
But then after that still got class.
How about the 24th one, change it to another day?
Yeah, you can change to another day. That means we need to choose a date to have the makeup.
Yeah.
She want to rest lah.
Wow. They should make noise on it if today they miss. And since next week it is 7 to 9, they might as well set another day.
Yeah, that's why. That's why I was thinking maybe I can extend today's class, but you say most of them are not coming, so
Yeah.
how? We choose another day so have a
Another day lah. But we check with them which day they okay lah.
Okay.
We talk about it next week.
By the way, we have another holiday on April. In April, I think it's like Good Friday.
Okay. Another day as well. But Good Friday I can come lah unless
I can come also.
I can come.
I can hear also, but it's a public holiday, so this one will not be open. The tutorial room.
Oh.
And book lah.
How to look?
Say that we have very good students want to come back.
Yeah. So we will be talking about what. Last time I finished the single amplifier, single transistor amplifier.
Yeah.
The AC, DC.
AC/DC.
Oh, have you tried the tutorial? Tutorials 5, 6, 7, 8, whatever. No?
No.
No?
No. I recently very busy with other classes.
Yeah.
Okay. But you have to try.
Okay. Anyway, we're going to start. We have to do our homework assignment.
Okay, so today we will be talking about what? Differential? I continue or
So 2007 is actually sorry, this is the answer sheet. You all have the
I don't figure out.
yeah.
tutorial 7.
Have we covered?
What's this?
Tutorial 7
Oh, really?
is
Got answer all the.
tutorial 7 is this one is still the previous. It's the same as tutorial 6. I think it's the assume blah blah blah. Find the small signal. Draw the small signal model. Find the voltage gain, whatever input resistance. This one is still your AC analysis.
But is there any difference?
I don't think so. It's just this structure has a special name which is called the bootstrap. This kind of structure. But anyway, it's still a single transistor circuit. You can use all the techniques to analyze this one. So you can find the voltage gain, input resistance, and output resistance.
Okay.
How to find this one is this one after you finish this part A, you can sub in the value.
Okay.
You need to go back and try.
Yeah.
Can I just look at the answer sheet? This part you really need to practice, otherwise you don't know.
Okay. So
Then question 2 and question 3 is the different the multi-stage amplifier.
just use the same method.
Yeah.
Okay.
Actually for this part, it's all the same method. It's just the structure change. Question 2 and 3 is the multi-stage amplifier. I think tutorial 8 will be on your differential amplifier.
Yeah.
Yeah, so maybe we cover multi-stage and differential today.
Okay.
Multi-stage. Actually, I can finish in one sentence because it's just you put multiple single stage together, then you form a multi-stage. That's all.
Okay.
But the way of how you analyze the circuit is the same as the single transistor amplifier. That's all. You see this, like for example, this kind of multi-stage amplifier. You have 2 transistors, right?
Yeah.
So each transistor is one stage 2. So you see this part. This part is actually is one single transistor amplifier. Then after that, they connect a cap to the next stage. Here is your second stage amplifier, single transistor amplifier. But basically, if you just separate them, they are just 2 individual single stage amplifier. So the way of analysis is the same as the previous one.
Okay.
Yeah. So this part you need to practice because there is nothing to talk about. It's just you need to practice. That's all.
Okay.
And how to redraw this one is the original circuit, right? How to redraw this one into its AC equivalent form? We need to follow the rules. How to convert original circuit to its AC equivalent form? The rules.
DC analysis first.
Okay. Let's say we know all the DC, the operating
Okay.
point already. Now I'm going to do my AC analysis. So how to redraw this one into its AC equivalent form?
Oh,
What are those rules?
like short voltage source.
What kind of voltage source?
The VCC.
If we have a DC source, DC voltage source, then we short it, right?
Yeah.
If we have a DC current source,
We
open, just remove the current source. Okay. If you have a capacitor,
open.
yeah, open. Open.
Short.
AC,
Short.
short, right?
Short.
So if you have a capacitor, you short it. If you have an inductor,
Open.
okay. Yeah. So that's all about how you redraw this guy into its AC equivalent form.
Okay.
After you redraw this guy into its AC equivalent form, you need to remember to replace your transistor by its equivalent hybrid pi model.
Okay.
If it's BJT, there will be 3 components, right?
Yeah.
What are the 3 components? Hybrid pi model,
R pi.
R pi, R out,
R out.
okay.
B G
GM.
GMVGS, okay. So no, if it's a BJT, so it's GMV BE, right? If it's a MOSFET,
VGS.
GMVGS, and your MOSFET only have 2 components, right? In its hybrid pi model. Your MOSFET doesn't have which one?
Don't have the R pi.
R pi, right? Okay, so it's GMVGS and your R out. So you just replace the transistor by its equivalent hybrid pi model. Then you just draw the external circuit accordingly.
Okay.
Then you do your AC analysis. It's exactly the same as what we talked about last time.
when the tutor went through the tutor 7, then there's this part where after she convert to the hybrid form, I think. Yeah, I think then there's this resistor over here. Then she said can what move it up to the base. Then she quite what refer don't know what technique is that. I don't know how to explain that. It's something that new to me. Like when she say when you put a resistor over here, then you I think it's divide 1 beta plus 1.
Ah, okay.
That's what refer. I don't
That
know.
one, after you attend the summary lecture, you will know. But we will talk about that this time. We can talk about it today. I know what you're talking about. That method is actually...
It's optional. That's
no,
just
that one is a shortcut which can help you to find I think it's the output resistance or input resistance, whatever resistance faster. Let's say, for example, you can refer to the notes. I will just use the notes example because I don't need to draw the AC equivalent. I can just copy. Okay. You refer to the notes, the multi-stage one.
yeah.
Yep, it's this example. Yeah, it's the same.
Okay.
Okay, for this one, it's just one example.
One page, yeah.
5A.
Fine, yeah, thank you.
You go to your multi-stage chapter, the first few pages. Okay. Basically for this chapter, the first 10 pages, I think. Anyway, before the differential amplifier, they're all talking about one example. They're all talking about this circuit. So original circuit is this one. And we can redraw this circuit into its AC equivalent form, which will look like this. Maybe I just copy.
It's like halfway.
Then after we finish, then we all got answer. You want to think all together. Yes. I got time.
Okay. Is that all? That's all right. Yeah. Okay.
Okay.
So this one is the AC equivalent form for that example. And just now you are talking about the beta plus 1 whatever, right? That one is to help you to kind of find the... You can use that technique to find a lot of things. Like for example, if you want to find the... If you want to find the, how to say, blah, blah, blah. If you want to find the second stage voltage gain,
Okay.
tell me where is the second stage voltage gain. It should be which one over which one, which voltage over which voltage. Where is your first stage?
The B2.
Where is your first stage?
B1.
Let me see. Wait. Okay. Yeah. Okay. Where's your first stage?
Why? How to tell which one is the first stage?
Look at original circuit.
Oh, okay. Oh.
Where's the output of your first stage? Look at the original circuit.
That's why it's the first stage.
First stage should be after a transistor, is it?
Yeah.
And
They actually divide the stage for you already.
Correct, yeah. It's just
Yes, tell me. Where is the output of your first stage?
it should be
Which point? Where is the output of your first stage?
See. Just try only. You all down here. You also want to lose space. This is what?
no, I think it's the drain there. The drain is
Why?
Where?
Drain.
the capacitor C3 that's
Yes.
Oh, why?
C3.
Why?
Yes. So
Because
C3, before the C3 is your first stage, right?
Yeah.
Before the C3 is your first stage, usually they will put a capacitor in between first stage output and second stage input to decouple the signal.
Oh.
So usually if you see this kind of capacitor in between, usually this capacitor is for decoupling. Okay, so before the C3 is your first stage, right? So the first stage output is at your M1 drain terminal, right?
Yeah.
Correct?
Yeah.
Because the M1 drain is connected to your C3, right?
Yeah.
Okay, so M1 drain is over here. Okay. So this one is your first stage, before this dotted line. Okay, so second stage will start from here until where?
C5. So
the next capacitor lah.
Okay, it's before C5, right? So it's the
It's connected
to where? It's connected to which terminal of which transistor? Which transistor? Which terminal?
That is called
base.
not base. Collector.
Collector, right?
Yeah.
Okay. So it's connected to your Q2 collector. So your Q2 collector is over here. Okay. So here is your second stage. Then this one is your third stage. So let's say maybe now the question is asking you to find the second stage voltage gain. So how to find?
Second stage.
Voltage gain.
So it's
So it will be which voltage over which voltage.
voltage
Which one?
over there at the C2.
Where?
Below
Here.
C2.
Yeah.
Okay.
To
So it's the voltage cross this RC2, right?
oh yeah.
Okay, so maybe let's call it what's the name? RC2 is RC2. RC2. Blah, blah. Okay, so maybe let's call it VC2. So it will be VC2 over
R pi 2.
where?
Across R pi 2.
So the voltage is
V2.
V2, right?
Yeah, V2.
Okay. So if you want to find this ratio, then how to find? How to find?
You can see it. China side. What?
Want to see here?
See there, see here. Okay.
How to find this ratio? How to find a VC2 expression and a V2 expression? How to find this voltage? This voltage. Maybe I take out this part of circuit, this part. Okay? Because actually this point is connected to here, right?
That one, that times the parallel to the resistor.
How? Yes.
Tell her. Tell me I
The
can't
G,
confirm.
the GM what V2 is
Yeah,
V2, then after that then times the parallel of the R out,
Which one?
R out to
This one?
parallel with the one that
Okay.
find the parallel, then you find the voltage.
How about the behind part? I still got this whole bulk here. How about this part? That idea is correct because you see, this current source is indicating it will draw this amount of current from this part, right? This part you can replace these two resistors by one, right?
Yeah.
So this current source is indicating it will draw this amount of current from this resistor and the behind part. Because you see this resistor, we can replace by one, right? So it's one resistor here. And the behind part, if we consider the behind part as a whole thing, it's actually this resistor in parallel with the behind part, right? So this current is actually drawing current from this resistor and the behind part. Correct? So the idea is correct. But now the problem is, this one I can calculate, this one I can calculate. How about the behind part? How should I treat this behind part? Imagine if this behind part can be summarized by one resistor, then the problem will be simple, right? It's just this resistor parallel with this resistor, right?
Yeah.
So now our question is how to convert this behind part into one resistor.
Parallel.
How to convert this behind part into one resistor? This concept is similar to your input resistance and output resistance, right? Your input resistance is withstanding at one point, then we convert whatever behind by one resistor, right? That resistor is the input resistance.
Yeah.
And the output resistance is also the same concept. We are standing at your output, then we look into the circuit, then then we convert whatever over there into one resistor. Okay, so the concept is similar. So how to replace this behind part by one resistor is actually how to find if we call this point input, it's actually to find the input resistance of this circuit. It's like we are sitting at here, then I have to find what's this Rin. Get it?
Yeah.
Where's the confusion? What's the confusion?
No.
No?
So
What's the confusion? Yes. Yes, question.
so should parallel them to make it one. Yeah.
If I can find one resistor which can replace this whole thing, then for this part it's just one resistor, two resistor, three resistor in parallel, right?
Yeah.
Then I just find these three resistance in parallel, then times this current, I can find this voltage, right?
Yeah.
Because these three resistor in parallel, they are sharing the same terminal, right?
Yeah.
So now the problem is how to find this one. How to find, any idea? The 1 plus beta, how to use?
I don't know.
Beta R5 plus beta plus 1
R hydrogen?
R5 3
R 3
plus
Plus?
beta plus 1
plus
the parallel, all those three resistor in parallel.
okay, so maybe let's call this one RL prime. Okay. So how? R pi 3
Plus
plus
beta plus 1 times that.
why?
Isn't it to find the RE?
Yeah, how? Why? Why? You derive from where?
Previous examples.
No, I can change the example.
Really?
Yeah.
Yes. If I call this whole thing R pi RL prime, right? I can remove this 3, then just leave 1, which is your RL prime, right? In RL prime is R out 3 in parallel with what? RE3 in parallel with RL. Okay. So how to find the so-called the equivalent resistance by looking at here, by looking from here. How to derive? Here is still your RR.
Yeah.
Okay. How to derive? Very simple. If you use the traditional method, which is introduced by the previous part of your notes, you can derive, but it will take you some time. So that's why your lecturer introduced this method, this tricks, which is the 1 plus beta. How to use that one? We look at the current. You tell me what's the current here? What's this one? This current. I leave this one. I don't combine this one together with all the rest. Okay. Tell me what's the current here?
I see.
This current is your I1. What's this terminal?
I see.
IC is not necessarily on top. It's not every on top nodes is your IC. It's not necessarily. Okay. This node is your E, right?
Yeah.
So the current going out of your E is your what? IE, right? So this one is your IE3.
Which one?
This current. Going through this R pi tree. What's this current?
I3
IB.
minus
I use another color. Oh, your camera.
IB.
IE3. Yes, this current is your
IB.
IB3, right?
Yeah.
Agree? Because you recall you need to be very familiarized with your hybrid pi model. This is your B terminal, this is your E terminal, this is your GMBBE, this is your output R out. This terminal is your C, this terminal is your E, this terminal is your B. So the current flowing through this R pi is your IB. This current flowing out of this node and this node, basically it's the current over here, right? Is your IE. The current flowing into your C, which will be split into this path and this path, is your IC. Okay, so where is your IC? So from B to E, through this R pi tree is your IB, right? All the current collected at your E node, which is out of this current source and this R out, this is your IE, right? Where is your IC?
GM3B3.
Where? It's from where to where?
The C3 going up.
C3 going up?
Yeah.
Where? IC is from whatever external into these two components, right? So where is it?
Right there.
Out 3 and 3.
R out 3 and
That means it's a bottom node.
where?
Yeah, going. Correct. Yeah, going that direction.
Left or right?
Right, to the right.
Okay, so it's wait, over
Yeah,
here.
yeah,
right?
correct.
The IC3.
Yeah.
Is that correct?
Still. Correct.
Actually, this current is not going from here to here. How to say? This current This current, if you look at this C node is connected to this node.
Yeah.
Can be connected to 1, 2, 3, 4, 5, whatever, right?
Yeah.
So if you look at your C node, it is connected to, we can plot this line, because this line is basically connected to the ground.
Okay.
Okay? So your C3 is actually here. So this current can be from here or
Yeah.
from here, right? Is that possible?
Yeah.
No, the question is that possible?
Can. Yeah. Anyways.
That will be IE3. Yeah.
Really? Oh yeah.
Where's the IC3? IC3 is actually just from the ground to these two components. Because this one is also connected to
No
the
one
ground.
can go the other way, so it's
Okay.
interesting.
You need to know the current direction. That one cannot be taught. I mean, you need to practice. Otherwise, you cannot tell exactly where is the current. Okay? So now we know the tree current. So now our target step is to find one resistance to replace whatever current. So you look at the circuit over here. Which part is so-called the troublesome part? Which part stop you from converting this whole circuit into one resistor?
Yeah.
This one, right? This one is a current source. So how to treat this current source? If this current source is not there, or this current source is a resistor, you can just simply use your whatever parallel in series. You can convert this whole part into one resistor, right? And now we have a current source. So how? What's the traditional method? Okay, the traditional method is to use Ohm's law, whatever, then find the voltage here and voltage there, right? So the 1 plus beta is a shortcut, which says that because I want to remove this one, right? Then I just remove it. I just remove it. After I remove this one, this circuit will change, right? I mean, something will change. So I need to know where is the change part, which part is changed. After I remove this current source, which parameter is changed? IE3 is changed. Why? Why? We look at the tree current, huh? This IB, is this one going to be changed? No, right? Because this one is your IB. It's from your B to C. Okay, so this one will not be changed. How about this current? This current which goes out this E node. How about this current? Will be changed, right? Why?
It add up both together.
Yeah, because your IE is the sum of your IB and IC. Yeah. If I remove this current source, that means my IC is changed, right? Because IC is the current flowing through these two components. And now I remove one.
Yeah.
So IC will be changed. And there is an assumption, which is we assume this R out is very, very large. Because if you do the experiment, you will find this R out. This one is over the BJT. If you do the experiment, you do the measurement, you will find this R out of your BJT or MOSFET. They're actually quite large. I mean, a few mega ohm. So it's quite large. So we can assume, because this one is quite large, so we can assume kind of the current flowing through this resistor is about. If the resistor is very large, so the current flowing through this resistor will be
Very large.
if the resistor is very large. The resistor is very large. The current flowing through this resistor will be about 0, right? So although your IC consists of this part current and this part current, we can kind of treat this one as 0. I mean the current flowing through this resistor. So it's about 0, the current here. So for this IC, we can approximate this IC by this current source, the current, right? So by removing this current source, it is kind of saying we are removing IC. But because your IE is the sum of your IB and IC, if I remove this one, my IE will just be this current. will just be my IB, which is not the same as our original circuit. The thing we want to do is, we want to remove some components, but the rest circuit still behave the same as the original one. But now I remove this one changed, this IE changed to IB, which is not the same as before because the previous IE is the sum of IB and IC. Now the IE is my IB only. So how to compensate for this one? How to compensate this one? If the original IE is IB plus IC, which is beta plus 1 IB, tell me what's this output voltage? This voltage will be? What's the voltage over here? This one is the original IE, right? It's the beta plus 1 times IB.
Yeah.
So what's the voltage here? The original voltage at this point? How to find a voltage across a resistor?
Just multiply RL.
Okay, so it's which one multiplied by R?
IE3.
Yeah, it's the original IE3 multiplied by RL prime, right?
Yeah.
It's the voltage here. So if we sub this formula into this one, we can find this relationship. So this one is the original voltage here. Agree?
Yeah.
Now my purpose is, after I remove this one, I want this node to be exactly the same as this one. So how? Because you see, if I remove this one, here the new IE3 will be IB, right? Then this voltage at this node will be IB times RL prime, right? Which is different from the original voltage. So how? You look at this formula and this formula, they are differ by. They are differ by beta plus 1, right?
Yeah.
This formula and this formula, they are just differ by 1 beta plus 1. One multiplying factor. So how to compensate for this effect? Is I just, after I remove this one, I change this one into beta plus 1 RL prime. If I change this one to beta plus 1 RL prime, this new IE is your IB, right? So the new voltage here will be IB times beta plus 1 times RL prime, which is exactly the same as the original one. Okay, so that's the beta plus 1 trick. If you don't, because this one is quite fast, if you are familiarized with this technique, you just look at the circuit, you can write. You can directly change this value into this one. It's everything by observation. You don't need to derive. In the exam, you can just write. You can just draw your AC equivalent. Then for this one, you don't write RL, you just write beta plus 1 RL.
Then just take out that.
Yeah.
Okay.
No, this resistor is still there.
Yeah.
It's just its value changed to beta plus 1
That's
RL.
it. That's so. If I want to remove a beta.
Yeah, you just take out. Usually you just take out.
Yeah, the rest I can just parallel.
Yeah.
Oh, okay.
So now your circuit become this one parallel with this one, in series with this one, then parallel with this one.
Okay.
Then this is your RF.
But that is only if my emitter is over there lah. If the circuit change, then
If the circuit change, you can still use this technique.
I still can.
Yeah.
Okay.
As soon as you want to remove this current source, you need to observe the tree current.
Okay.
Which one is changed? Then you can change the resistance accordingly.
But anyway, what I'm talking about is not this. It's
The beta
something else.
plus one is this one.
No, she was talking about another stuff. It's not this one.
No, just now you mentioned beta plus one, then
Yeah,
we
yeah.
move, right? So should be this one.
She removed the resistor, not the emitter. I think it's
Move
another.
the resistor.
I think it's a BJ. It's actually it's still a BJT that time.
Okay, then.
Then I don't know. She was doing some calculation, thinking that the resistor should put at the base, make it series. So there's a calculation.
Oh, that one maybe it's just some after you convert the original circuit into an AC equivalent form,
Oh, yeah.
the circuit may look like a bit weird, so you move the components apart to make it look like this lah.
Oh, yeah, okay.
Because you see, for this part, our E is on top, right?
Yeah.
If you want to draw this E, like in a traditional way, we usually draw E at the bottom, right? For this transistor, because of the connection, if you want to draw this E here, the circuit will be a bit weird. I mean, it's not, it will not help in circuit analysis.
Okay.
So that's why we draw this E on top. It's kind of as long as the sequence, I mean, all the sequence of your resistor and the direction of your GMVB, the current source, is still the same. You can move all this around to make a circuit look nicer.
But it's still different from.
That's all about B, because just now you mentioned beta plus one. The only beta plus one is over here.
Next week I'll give you a better.
Okay. The other one is RL over beta plus one.
Okay.
Because you can, if you can times this RL with beta plus one, then you can divide it, right?
Mm.
So that depends on the circuit. No. Okay. So by using that observation, you can just observe, right? You can just replace, remove whatever you can find this R in. Because R in parallel with this one, in parallel with this one, then these three in parallel times this current, you can get the voltage here, right? It's your VC2. VC2. So you get an expression for your VC2. So this V2 is just this RB times this R pi 2.
Yeah.
Then you can just let me see. Because if you see over here, this definitely whatever expression over here will contains your IB, ID3, ID2, whatever, IB, okay? And here is your IB, then you can do the cancellation, whatever, you can get the expression.
You will.
Now this one is your multi-stage amplifier. Basically, the only trick here you can use is this one. Is this beta plus 1 times beta plus 1 divided by beta plus 1. The rest is exactly the same as your single transistor amplifier. Because multi-stage is just cascading 2 stages of your single transistor amplifier or 3 stages. It cannot be more than 3 stages, right? If it's more than 3 stages, you will take 1 hour maybe to solve the circuit. So this kind of circuit will not appear in exam. Usually exam, I think 2 stages is enough. Because your single transistor amplifier is something like this. This one is a single stage, single transistor amplifier, right? Basically, it's the amplifier, right? Here is your V in, here is your V out. So if you want to draw it as a symbol, you can just draw it as a symbol. You have a V in, then you will have a V out. It will be amplified by whatever, 8 times. Okay? So the multi-stage is just this 8 times cascade with another, maybe V times cascade with another C times. Then now here is your V out, here is your V in.
Actually, why use transistor to amplify when you can use op amp? Like, what's the difference?
Because op amp consists of a few transistors, maybe 30, 40.
Okay, then
Single transistor amplifier only has 1 transistor.
also transistor is a better amplifier.
No. It is to simplify, because this course is a basic analog course.
Yeah.
So it cannot ask you to analyze the op amp circuit.
Okay.
The op amp you see is a triangle, right?
Yeah.
Triangle, but inside this triangle we have this kind of a structure. Blah blah blah. And what's the structure? Resistor. Then after here you got another stage. Blah 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 blah. Then
So
we have a
our
lot.
op amp is the transistor part is the more in depth of op amp, is it?
No, your op amp is built by transistors.
Yeah. So right now we are learning transistor. It's actually how it works inside op amp, is it?
No,
No.
this single transistor amplifier is just to show you one single transistor can be used as an amplifier and tell you how to do AC analysis, the concept. Then you can apply this concept to analyze other kind of circuit. If you go to year 4, you choose the elective, the advanced analog, they will tell you how to use you are required to use the AC analysis techniques to analyze your op amp circuit. So this one is just like an example lah. Like an example to teach you how to do your AC analysis. But anyway, my point is the multi-stage amplifier is just cascading a few stages of this single transistor amplifier. So you use the single transistor amplifier analysis to analyze your multi-stage amplifier.
You got question, right?
Yep.
Yeah, just answer. She will help one. Yeah? Yes. But no, at least you got effort. Just like show her the working and then see what.
Yes.
Yes, show her. Yeah. Huh?
Have you done?
No, I haven't start yet. I haven't start. You need to work with Max Max 2 啊
Yeah, this one is cute.
Max 1 是
This transistor is
Max 1
called
是
No. Inside the question, I mean inside the circuit, right? If you see this kind of transistor circuit, whatever, they will usually give a name for this transistor. Sometimes they call it M1 or M2 or Q or A, B, C, D.
doesn't matter.
It doesn't matter. It's just a name for this transistor. So sometimes they will call this transistor Q. That means this transistor, the name for this transistor is Q. So if the question is asking you to find the VB, VCB of Q, it means that they are asking you to find the VB, VCB of this transistor. There's nothing to do with the Q point.
Oh, also is Q point.
No. They never say Q point. It means that it's not Q point. Okay? If they ask you to find the Q point, they will say Q point. Yeah.
Next question.
Yes.
Next one very tough.
Why not you draw your answer and like question one, you see correct or not? Correct, right?
For the last one, the part K, what's the maximum amplitude of the input signal VI to maintain small signal operation? This one, we talked about this one last time. Is to use a small signal limit equation. You just use that equation, submit. Just sub whatever value you have into that equation, you can calculate this small signal. This maximum amplitude. Because that one is a small signal limit, right? So that means the signal cannot succeed that limit. So which means that the one is this so-called the maximum amplitude.
How about we do it together?
No, I cannot go through this question with you. Because this one is an assignment.
But we do it, then you
Like you go through this one, like how, like example, how you do the reverse one. If let's say the RC, this one.
What others do?
Then
RC?
after register value remain as RC, then they need to find the maximum value of RC to keep transistor in the forward.
Yeah.
How to do it? This one I don't understand. Does it show an example?
The example is in the
对
tutorial.
整片的啦，对整片
Tutorial, I
整
think
片的
it's
啦，
this
看到有
DC
这
and
是
this
digital
one.
Then go to
assignment
tutorial.
I go through that
experience
also
already.
already and last time.
Huh?
The question which asks you to find the operating region of your transistor.
讲这个都是过了。
How to find the operating region of your transistor? It's inside the tutorial. I think it's tutorial. Which one? The question one. What's the operating region of transistor?
Oh, the saturation stuff like that.
Yes. The question is asking you. The question is actually asking you to find a resistance value so that that transistor can be in the same. What's the question? The transistor can work in the same region, right?
Yeah, then is the maximum value.
So first of all, you need to know what's the operating region of your current transistor. Okay? After you know the working region of your current transistor, definitely you will write a few equations, right? The equation will contain your RC. Then you just try the value, just by observation, to find the value of your RC, which can keep this transistor in the same region.
I don't get it.
VCE equation.
VCE.
You can compare with BBE, right?
Yeah.
Find your RC.
First of all, you need to get the current operating region of your transistor. I think no, this one actually. Yeah, it's this one. The small signal limit is the equation for VBE is this one. They just move the terms because VE is this expression, right? VBE is VB minus VE. So you just sub this VE expression into this one, then they get this one.
我忘记了，我要
But actually the
回去把你
equation
再
is
看
this。one. Your VBE must be less than 0.025. This one is the equation. But this one is for BJT only. For most part, you have another. Yeah.
Look like we need to revise old chapter.
That's your assignment. You need to do by yourself. You can discuss, but I cannot tell you.
Let's discuss. You just like
No, you can discuss by among yourself, but I cannot tell you.
Then you go through the tutorial, you say the question.
how about refresh?
I still don't get it.
Today refresh.
I went through that tutorial already.
Again.
I went through that question already. Today we need to finish the differential amplifier.
Yeah. Anyway, she 24 plot free. So we thinking whether.
Yeah, by the way, I will be on leave on 24. So So we need to have a
Friday
makeup all weekend.
周末那个也是 Friday，他也是 Friday 刚刚好。
Or we can have 1 hour extension.
I thinking like just one lesson lah. Monday, Thursday, or
Hello.
还是 Thursday 可以吗
So we have 1 makeup or we
Thursday,
have 2
Thursday.
extensions.
有做吗？
应该偏 theory，
啊？
偏 theory。
哦，有别的 tutorial 啊。
对，圈下来嘛，Tuesday 啊，Monday 啊，
对，有时候
然后就开。
So we have 1
next
makeup
week
session.
7 to 9 already.
Yeah, next week.
Cannot next week.
Because I want all of you to attend the lecture. Please go. Seriously, please go.
Why?
There's a reason, please go.
Oh my god, give tips ah.
Okay, it's the one who write these lecture notes.
Morning 2 hours lah, then after you break, you go the lecture.
Okay. idea.
Morning ah.
You
Afternoon
will have
lah.
class, right?
Afternoon 我们那个 lecture 嘛。
No， 那个 is 4:30 to 6:30吗？然后 morning then 我啊，
之前啊。
啊那之前 anytime before 4:30啊，like 1:30 Friday 1:30
Leave the whole day there. How do you?
Oh,
1:30.
no.
Oh, which day?
next week
Oh,
Friday.
Next week Friday. Okay. Okay.
Thursday 他不可以。
Anyway, we can make up like at the nearer to our exam what, we can push it there.
反正他没有欠了嘛。
OK 咯
We
，can
can
咯
push it to closer to exam lah.
can
So
咯
we just forget about it first. So that you have 1 lesson.
Anyway, she covering differential
No,
today
no,
what?
no, no,
Differential
no,
of what?
You will have another holiday in April, which is the Good Friday. So you need to make up for that one also.
So 2
If you want to push the 2
If
session to near the exam,
but Good Friday no matter what cannot get a room ah. That's
think
important.
so.
If can, we can straight away do 4 hours of that day.
Yeah, yes, but I need to ask lah.
If possible, then we go Friday or daytime lah, not night time lah. You go church ah.
I need to ask lah. If you all agree on Good Friday, can. But I need to ask about Good Friday. Yes?
Yeah.
No?
Good Friday, yeah. One shot 4
No.
hours.
只是前面 DC。
Got holiday plan. So Good Friday
Okay.
Aye.
Friday?
Yeah.
Afternoon?
Yeah, after
What time?
1:30 like that.
4 hours until 5:30.
1:30 to 5:30.
So can lah. Can lah.
I ask.
Okay.
Actually,
Yeah, one shot lah.
很爽啦。
One shot.
哇哇，然后再 break。
这个
But anyway, we should cover differential amplifier today. Differential amplifier is quite a short chapter and it's quite simple, I would say. So you should master it. So what's differential amplifier?
2 inputs.
amplifier is a bit special. It's a special kind of a circuit. So the circuit structure is fixed. So yeah, it's like as long as you see this kind of circuit structure, it is a differential amplifier. So the structure, yeah, it's notes. Okay. For differential amplifier, the last few pages is out of syllabus, right? I don't know what I'm asking. No, it's not. No, it's not. It's not this part. Okay, but anyway, everything is inside syllabus. The structure given by a lecturer is this one. Okay, so this one is the structure of your differential amplifier. Basically, it's just one differential pair. Okay, together with some resistor. And you can see it's symmetrical, right? Okay. So where is the input for this amplifier?
Yeah, right.
This one and this one, right? So that maybe let's just call it V plus or V minus. Where's the output?
IE.
Where?
IE.
Output. Where's the output node? The output node is here. Here, V out 1, V out 2. Okay. So this kind of a differential amplifier, it has two inputs, two outputs, right? So how to do the circuit analysis? Steps.
One side of
Steps.
step one, cut it. Divide the circuit.
So you split the circuit, right?
Yes.
How to split?
Oh, VCC, cut.
So you just split the circuit along this central line, right?
Yes.
Then how about the components along this line?
Means both sides got VCC.
Okay.
RE.
So here you have VCC. Here you have VCC. RE. How? What do you mean by the same?
Means cut both side.
Okay. Then what's this and what's this? REE.
The two line.
2 RE, right? Because originally it's one resistor. Okay. Now I want to split this one into two. So these two are actually in parallel, right? And these two, the equivalent resistance need to be the same as the original resistor, right? So original is REE. So if you replace it, if you want to get the equivalent resistance of REE by paralleling two resistors, each will be 2 times of your REE. Okay, so Yeah, we split the circuit already then.
VCC grounded.
Ground VCC, why? Why? You know. Now you need to ask yourself, what kind of analysis you are doing? Let's say, for example, I want to ask you to find a Q point of this transistor. These two transistors, I want to find their Q points. Okay? If I want to find the Q points for this transistor, what's the second step? After I split the circuit, I should
DC.
check.
Which region?
Which region do I really need to check? If you want to use transistor as the differential pair, these two transistor diode must work in saturation. For BJT, must be forward active. For MOSFET, it will be saturation. Okay, otherwise they cannot be used as differential pair. Okay, so if I want to find the Q point for these two transistors, what's the second step after I split the circuit? DC equivalent, right? DC equivalent circuit. So how is the DC equivalent circuit look like? Arrow. This one is still our original circuit. Take note, this one we haven't do any transformation, right? It's still our circuit. It's just we split them into two. You see, this line still connect these two together. So these two resistors is actually in parallel. I can combine them to form our original REE. And these two I can still connect them together to form the original circuit. So this one is still our original circuit. So if I want you to find the Q point of these two transistors, I need to transform this circuit into its DC equivalent form, right?
You withdraw.
Withdraw? How do we withdraw?
Withdraw the thing into.
Yes, like pump, draw. Pump.
I'm learning this for the first time.
Okay, you draw over there.
Might have error because I have not seen this before. Well, it's actually BCC, but they ground it somehow. Why need to ground?
You draw the DC equivalent first.
Then
You look at the circuit. How to draw the DC equivalent. DC equivalent. I want to find the Q point of the two transistors. Yeah, I think so.
Then this is the wrong one.
You just draw half of it.
How to find the DC Q point? How do you do the DC analysis for previous part? That's why I say this part is all about concept. You need to learn the techniques. It's not about the circuit, how the circuit look like. As long as you learn the technique.
It's on page 29.
It's on page 29.
Yes, DC half circuit.
在玩水部，他是那个因为我没有看，不是很大的，现在他后来。
I can just put V in one, V in two. Yeah, V in one.
It's actually on page 30. Yeah, page 30 is the correct one.
他想用回旧的 TCM
第二个是
第二个是旧的 concept 他可以 FTJ 本来是没有的 well this year
Thank you. So, is this one correct? DC equivalent. DC equivalent. Is this one correct?
No, no, that is D. Look at your page 30.
Is this one correct?
correct
see what's that.
yeah
How to draw a DC equivalent circuit? How to draw a DC equivalent circuit? What are those rules? Remove AC source, keep DC source, right?
wrong side
So you cannot draw ground here. Okay, here is your DC source, it's your VCC, VCC. Okay. How about the AC source?
keep
How do we
Yeah.
remove the voltage AC source?
ground
AC voltage source. Short this AC voltage source, right? So you short the two terminal of your voltage source, it will become like this. Yeah. So this one is your DC equivalent circuit for your differential amplifier. Isn't this circuit very, very, very basic?
Yeah.
It's just one resistor, one transistor, two resistor. It's much, much simpler than your single transistor amplifier, the DC equivalent. So now your target is to find your Q point, right? Q point. So Q point is what? What's Q point? IC.